Imagine looking at Earth not as a map of countries, but as a living system recorded in rock, ice, mud, lakes, oceans, fossils, chemicals, and atmosphere. For most of human history, we were one species among many, adapting to the planet's rhythms. But over time, especially in the last few centuries, and most dramatically in the last 100 years, humans stopped being only passengers on Earth. We became a force capable of changing the planet itself. Forests disappeared, cities expanded, rivers were dammed, carbon dioxide rose, species vanished, plastics spread, and radioactive traces settled into sediments. The word Anthropocene was created to capture that shift. It means, in simple terms, a proposed age of humans, a time when human activity became powerful enough to leave a planetary signature. The Anthropocene is often described as a new geological epoch, but that phrase can be misleading unless we understand what geologists mean by an epoch. Geological time is not just a poetic timeline. It is a formal system built from physical evidence in Earth's layers. The Holocene, the epoch we officially still live in, began after the last major ice age, around 11,700 years ago. It includes the stable climate period in which agriculture, cities, writing, states, trade networks, and modern civilization developed. The Anthropocene proposal argued that the Holocene no longer fully describes the world humans have created. According to this view, the planet crossed into a new state, not because nature changed by itself, but because one species began altering climate, chemistry, ecosystems, and sediment patterns at global scale. The word itself has an interesting history. Biologist Eugene Stormer used the term Anthropocene informally in the 1980s to describe the growing human influence on the planet. Later, Nobel Prize-winning atmospheric chemist Paul Crutzen helped popularize it, giving the idea a much larger audience. Crutzen's argument was not that humans had simply damaged nature in isolated places. His point was bigger: human activity had become comparable to geological forces. Burning fossil fuels changed atmospheric chemistry. Industrial agriculture changed nitrogen and phosphorus cycles. Mining moved enormous quantities of rock and soil. Urbanization created new artificial landscapes. The term quickly spread because it gave scientists, environmental thinkers, economists, politicians, and the public a shared language for something many fields were already observing from different angles. One reason the Anthropocene became so influential is that human impact is not limited to climate change. Climate is a major part of the story, but not the whole story. Biodiversity loss shows that ecosystems are being reorganized, sometimes permanently. Land use changes reveal how forests, wetlands, grasslands, and coastlines have been transformed into farms, roads, suburbs, ports, and extraction zones. Water systems have been redirected through dams, irrigation, reservoirs, drainage projects, and groundwater pumping. Even salt cycles and sediment flows have changed because of mining, agriculture, and infrastructure. In lakes and oceans, particles from industry, fertilizers, heavy metals, microplastics, and combustion residues can settle into layers. The Anthropocene concept links all these signals into one question: what does Earth look like when human systems become planetary systems? But if the Anthropocene is an age of human impact, when did it begin? That question became one of the central problems. Some researchers suggested it could start with the Neolithic Revolution, when agriculture began roughly 12,000 to 15,000 years ago. Farming changed landscapes, domesticated plants and animals, and began long-term human modification of ecosystems. Others pointed to the Industrial Revolution, when coal, steam power, factories, and mass production accelerated fossil fuel use. Another option was the early colonial period, when global trade, disease, slavery, plantation economies, and biological exchange reshaped ecosystems and human societies across continents. Each date tells a different story. A very early start emphasizes agriculture. An industrial start emphasizes fossil fuels. A colonial start emphasizes global integration and disruption. The most formal Anthropocene proposal, however, focused on the mid-20th century, especially around 1950. This was not random. After World War II, the world entered what researchers call the Great Acceleration. Population growth, economic output, energy use, fertilizer consumption, water use, transportation, plastics, pollution, and resource extraction all rose sharply. The scale and speed of change were unlike earlier periods. At the same time, the atomic age introduced a very specific global marker: radioactive fallout from nuclear weapons testing. These particles spread around the world and settled into sediments, ice, soils, and biological materials. For geologists searching for a clear boundary in Earth's record, this mattered. A formal epoch needs a trace that can be identified globally, not just a general feeling that the world has changed. To turn the Anthropocene from a useful concept into an official geological unit, scientists needed more than a persuasive story. They needed a formal marker known as a golden spike, or GSSP, which stands for Global Boundary Stratotype Section and Point. A golden spike is a specific physical reference point used to define the lower boundary of a geological time unit. In other words, it answers the question, where, exactly, can we point to Earth's layers and say, here is where this new chapter begins? The Anthropocene Working Group, operating within the formal structures of international stratigraphy, spent years studying possible markers. They considered signals such as plutonium from nuclear testing, industrial particles, chemical changes, biological shifts, and other evidence preserved in sediments. By 2023, the leading proposed site was Crawford Lake in the Halton region of Canada. Crawford Lake attracted attention because its sediments preserve unusually clear annual layers, almost like pages in a book. These layers can trap evidence of environmental change with fine time resolution. The proposal suggested that sediments there could mark the beginning of an Anthropocene epoch around 1950, even giving the possible stage or age the name Crawfordian. This site was not chosen because Canada alone defined the Anthropocene. It was chosen because a formal geological boundary needs one reference location that represents a global signal. Crawford Lake's sediments appeared to preserve the mid-20th century transformation in a way that could be studied, dated, and compared with records elsewhere. Then came the decision that surprised many people outside geology. In 2024, after about 15 years of deliberation, the formal proposal to add the Anthropocene epoch to the geologic timescale was rejected. The Subcommission on Quaternary Stratigraphy voted it down by a wide margin, and the International Commission on Stratigraphy and the International Union of Geological Sciences later confirmed the rejection. The main concerns included the extremely recent proposed start date and the shallow sedimentary record. Geological time usually deals with boundaries that can be tested across deep time and preserved in durable records. A boundary beginning around 1950 is scientifically interesting, but it is also very young. For many stratigraphers, the evidence did not justify creating a formal epoch within the official timescale. This rejection does not mean scientists deny human impact on Earth. That is an important distinction. The decision was not a vote on whether climate change is real, whether biodiversity loss matters, or whether humans have transformed the planet. It was a technical decision about geological classification. Stratigraphy has strict rules because the geologic timescale is meant to be stable, precise, and useful across many branches of Earth science. Some critics of the proposal argued that the Anthropocene is better understood as an ongoing event, a process, or an informal concept rather than a formal epoch. In that view, humans are undeniably changing Earth, but the official geological clock should not be reset based on a boundary that is only decades old. Even after rejection, the Anthropocene remains powerful because it names a real transformation. The International Union of Geological Sciences itself acknowledged that the term will continue to be used by earth scientists, environmental scientists, social scientists, politicians, economists, and the wider public. That matters because the Anthropocene is more than a label for rocks. It is a way of seeing connections. A smartphone depends on mining, energy grids, shipping networks, rare elements, factories, labor systems, and waste streams. A supermarket depends on fertilizers, refrigerated transport, global agriculture, plastic packaging, and water use. A city depends on concrete, steel, electricity, roads, sewage, and constant resource flows. The Anthropocene asks us to see these everyday systems as geological forces in motion. So the Anthropocene sits in an unusual position. Officially, we still live in the Holocene. Formally, the proposed Anthropocene epoch was rejected. But intellectually, the term is not going away, because the evidence behind it is visible everywhere. In warming temperatures, altered rivers, shrinking habitats, mass production, nuclear traces, plastic fragments, and the reshaping of land and life. The key lesson is not simply that humans are destructive. It is that humans have become powerful enough to change planetary conditions, often without fully understanding the consequences. Whether the Anthropocene is ever accepted as a formal epoch or remains an informal descriptor, it forces one uncomfortable question. If humanity has become a geological force, can it also become a responsible one? If you found this helpful, please like this video and subscribe for more explainers.